Are able to hear those are online?
Yes, sir.
Okay, listen. Abhinav, you remember what was the last concept taught?
Yes, sir.
What was it?
1 second. So we were looking at chemical bonds and structures and bond parameters.
Bonds. Chemical bonds.
Yes, sir. That chapter, sir, we are looking at bond parameters, etc.
Topic was dealt is what I'm asking.
Sir,
In that chapter, what subtopic was being dealt?
yes, sir. Bond parameters.
One parameters.
Yes, sir.
One parameters na the kappa ಇದನ್ನ ಸರ್ one parameter. ಇದು ಅದೇ ಇದು ಆರ್ಗ್ಯಾನಿಕ್ ಪ್ರಯೋಗ. Okay. Yeah, you can actually test them. So listen, guys. Like from last week, sir, make sure I think telling this from the beginning. Make sure that the classes are interactive. The reason why I asked you guys to come here is because of the see what is the scenario of online classes. Even I took one class and I had to literally train for the people. One more parents. That's not going to be encouraged to inform. I'm going to take this very simple. Be very simple. Make sure you're coming here to attend those classes. Is it clear to people or online? Today it is fine, but next time onwards it will not be excused. You make sure that you're coming here to and you have any doubts, ensure it. Not like go home, sit and have multiple doubts. So the scenario you want to take what was the last topic. I remember if you open the video and see last week, I remember hybridization being taught. And I repeat, without the chapter, you can forget organic chemistry. It is not going to be like a 10th standard where you memorize IUPAC names and then you need to understand mechanisms. You need to know the bond structures are present. Only then you are going to speak about the reactions taking place. Please be sure that it is interactive and get your doubts clarified. It's not that I want to do for us. To clear your view and be very simple. So outside of that, we are ready to make sure you get it done. Yeah. So let's get started. Sir, you can start with what is the topic? Just test that. So first, okay, let's interact with you. You have to speak out. Tell what are you want. Is it clear? So you can ask one by one. And you will share screen at still. Thank you. Thank you. Yes. Yes. Okay. Chemical bondings. What do you know about the chemical bondings? What are the topics you know about the chemical bondings? Pause. Then different types of bonds. Different types of bonds. What are the types of bonds? Okay. Types of bond. Any other things? How you are writing the structure of the molecules? What is molecules? What is atom? Why it combines so? To attain stability. For the combination to attain the stability. Okay. So what is atom? Smallest in
Indivisible. That's what atom. So in the atom you have this combined it will form molecules. So we are having atom 1 and atom 2. Okay, when you are taking atom, for example, simplest one, you are taking hydrogen atom. It has only one electron. When it combined with one more hydrogen, it gives hydrogen molecules. So molecules means more than one atom. As you say, when the atom combine, it will form molecule to attain the state. Okay. Now we have to see how the structure of the hydrogen molecule. What is the distance between the two hydrogen atoms? So far you have studied the bonding parameters, bond length, bond energy, then what else? Bond angle. What is bond angle? What is bond angle? So what is bond length? What is bond length? Huh? Then better answer. You say the atom is indivisible particle. Hmm? Very good. Distance between the two nucleus in the bond. So when you are taken, nucleus means you have proton and neutron. So the electrons are surrounded the proton and neutron. So the internuclear distance between the two atoms. So you are taken, this is the center of the atom, this will be the center of the atom. So this is called bond length. Okay. What is bond angle? What is bond angle? What is bond angle? Okay, bond. What is bond energy? Tell me, what is bond energy? The energy needed to separate the bond. Very good. Break the bond. Very good. The energy required to break the bond is bond energy. So what? Bond energy is gravity between two bonds. So saying this is very good. So you know the bond angle, bond length, and bond energy. So what is the relationship between bond energy and bond angle? So you have bond length and bond order. What is bond order? Number of bond. So what is the relationship between bond energy and bond order? Higher the energy? Higher the bond. Okay. Bond energy is that. Then if you are connecting with bond length? The bond length is inversely proportional to bond. So bond order is directly proportional to bond. Bond is so is it right? Okay. So you keep this in mind. Okay. When the molecules are given, you have to identify whether it is singly bonded or doubly bonded or triply bonded. Okay. From that you can answer simply. So this will be the bond energy. Given bond energy, you can select it. Okay. For example, I given H2 molecule, N2 molecule, O2 molecule, O2 plus molecule. At the end of the chapter, you come to know what is the bond order between O2, O2 plus, N2 and H2. Simply, if they are given means you have to choose what is the bond order and how the energy become. You are not experimentally proving, but theoretically you can say, so this will be the bond order. So the bond energy will be in the order like that. Okay. So these are the bonding phenomena. First, you are saying, so for shapes, what is shape? How you are giving the shape or geometry? What is geometry? What is shape? Structure of bond of molecules. Structure of molecules. So what is the difference between shapes and geometry? If you understand, chemical bonding over. What is shapes? What is geometry? Angular? Okay, 50% okay. So what is the shape of H2O molecule? Bent. What is the hybridization of H2O molecule? Correct. Bent is right. When you are finding the hybridization, it becomes sp3 hybridization. If it is sp3 hybridization, what is the shape? sp, sp2, sp3. So sp means you are going to have two become linear. Generally, sp2 triangular, sp3 tetrahedral. So when you are calculating the hybridization of oxygen molecule, it becomes sp3. So what is that geometry of that molecule? But you are saying bent. How it is bent? O will become. You draw it in your note.
டேய் வா ஹெல்ப் பண்ணுவா அது ஃப்ரீ ஃபயர் இருக்கா இல்ல ஃப்ரீ ஃபயர் தனி முடிச்சு கொடு ஃபர்ஸ்ட் மா எத்தனை மணிக்கு போலாம்
Okay. So at last we can know how to calculate hybridization. Okay. So what is the hybridization of the atom? What is the shape? What is the geometry? That we can come to the conclusion later. Okay. First we'll start with the BSCPR theory. Okay. Before going there, you should know the Lewis structure of the molecule. So many theories has been proposed for the bonding of molecules. So you know that when the more than one atom combined means it will form the molecule. There is no doubt about it. Okay. When the A atom is combined with the B, it gives AB. So the bonding is A bonded with B. When it combines with one more B means it will give AB2, ABB like that. So that ABB will be like this. Correct? Linear or it may be bent. Whatever it may be. Okay, so we have to find out how the structure of molecule will be. First, finally we come to the conclusion. Okay, just to understand, Lewis structures means you have to find out the central atom and the peripheral atom. Central atom means the least atom in the molecule. Peripheral atom means more number of atom. If you are writing AB2, you have only one A, two B. Then A is the central atom, B is the peripheral atom. Okay, and then you have to find out what is the valence electron of the central atom and what is the valency of the attached atom. So simply I will say, if you know the p block element, anyhow you are going to study the p block element. First you should know alkali metals, alkaline earth metals, p block elements. In the p block elements you have boron, carbon, nitrogen, oxygen, fluorine, neon. Am I right? So in the boron family, we have boron, aluminium, gallium, indium, barium.
ஏன்பா
Carbon family, carbon,
குடிச்சிட்டேன்டா குடிச்சிட்டேன் போடு போடுற நீ என்ன பண்ற ஏன் பண்ற? ஆ? உள்ள சாப்பிடுறியா போயிட்டு அப்படியே மோட்டர் போட்டு எல்லாம் லைட் போட்டு விட்டு வந்துரு போ.
so the carbon family, we have carbon, silicon, germanium, tin, and lead. Nitrogen family, nitrogen, phosphorus, arsenic, antimony, bismuth. Oxygen, sulfur, selenium, tellurium, polonium. Fluorine, chlorine, bromine, iodine, astatine. Helium, neon, argon, krypton, xenon, radon. Okay. So in the bottom series, we will not take in account because of the radioactive nature. Okay. Why I am choosing this? No. If you have taken boron family, the general electronic configuration is NS2 NP1. NS2 NP1. Okay. Carbon NS2 NP2. NS2 NP3. NS2 NP4. NS2 NP5. Sorry. This is NS2 NP6. The valence electron means when you have the nucleus, the electron will be surrounded in the circle path, that is known as orbit, the last orbit, okay, known as valence orbit. If the electron present in the last orbit, it's known as valence electron. Okay, so you know that it is K shell, L shell, M shell, N shell, whatever it is. So in the p block element, the general electronic configuration is NS2 NP126. Okay, so if you are counting this family, you have 3 electrons. Here it has 4 electron. Here it is 3 electron, 4 electron, right? This is 5 electron, 6 electron, 7 electron, 8 electron. Correct? If you are finding the valency, generally you can take the valence electron or minus it. Okay, so you can take 3, 4, okay, 5 or 8 minus 5, because nitrogen will become more than half filled. The periodic properties, you can see that halfly filled element have more stability than the not completely filled and half filled have the more stability because of the higher exchange energy. So it has 3, here 2, here 1 and 0. So the valency of the element of the p plus 3, 4, 3, 2, 1, 0. Up to carbon, you have to take the final electron. Nitrogen, because of the half filled, you have to take 8 minus. Okay, valence. But the total valence electron, you have to take this one. Okay, for the boron family, 3, 4, carbon 4, nitrogen 5, oxygen 6, fluorine 7, and neon 8 inert gas. When you have the alkali metals, what are the alkali metal? Lithium, sodium, potassium, rubidium, cesium, francium. Correct? Beryllium, magnesium, calcium, strontium, barium, radium. If you have, it is NS1, it is NS2. So 1, 2 balance. Okay, is it clear? Is it clear now? Now we'll go. So you have to keep this in mind. When you're going +1, +2, whatever it is, if you know this, any molecule, you can find out the structure or shapes or whatever it is. Okay, shall we go to the next one? When you are writing Lewis structure, for example, AlCl3, you are writing. So what is the central atom? Aluminum is the central atom. So 3 chlorine atoms are attached. Okay, you go to this aluminum, where it comes in the, it has 3 electrons surrounded. Okay, 1, 2, 3. Chlorine means it's coming under here. How many electrons? 7 electrons. So Cl 1, 2, 3, 4, 5, 6, 7. When the chlorine is combined out of it, so Al 1 X 1 dot Cl. Okay. So now, if you see that around the chlorine atom, it has 8 electrons. Am I right? You calculate 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. But around the aluminium, how many electron you calculate? 6. So if you are writing the valence electron, you are taking only the valence electron and writing the simple structure, means this is known as Lewis structure. Okay. For example, we can write any molecule. You can tell me. Either or molecule solunga. NH3, yeah. NH3. Nitrogen means 5 electron, right? Am I right? 1, 2, 3, 4, 5. And hydrogen means 1 electron. 1, 1, 1. So hydrogen. So hydrogen can accommodate only 2 electrons. Except for hydrogen helium, it can accommodate only 2 electrons. Okay, remaining only it has 8 electrons. So around the nitrogen, how much it will be there? Calculate the red circle. We have 2, 4, 6, 8. So 8 electrons. And then where are the molecule? C. So carbon is 4. Okay, we can write carbon 1, 2, 3, 4. Chlorine is 7, right? 1, 2, 3, 4, 5, 6, 7. So now 8 electron, 8 electron, 8 electron, 8 electron. In that you calculate the electron around the carbon, the red circle. Around the chlorine, around each chlorine will become 8 electron. If the atom surrounded with 8 electron, it has acted. Okay, then it becomes more stable as per Lewis structure. But there is some limitation. If you take NH3, AlCl3, it's a stable molecule, but the aluminum surrounded with only 6 electrons. But it is a stable molecule. But it needs 2 more electrons. Okay, that is why AlCl3 can be exist as Al2Cl6. That's why it get dimerized. So you are saying AlC3 is a Lewis acid because 2 electron deficient. When it gives 2 electron, it becomes stable. Yeah. It's okay? Clear? If you try with PCl3 and PCl5, PCl3 and PCl5. What is the phosphorus valence electron? Nitrogen family 5 only 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. When you take the chlorine atom, you try yourself. Around the phosphorus, it become 2, 4, 6, 8 here, right? Around the chlorine, it become 8. So octet is filled, it is stable molecule, right? When you come to PCl5, around the phosphorus, it become how many? How many, ma? Around the phosphorus, how many it become? Huh? 10. But it is also stable. So it is a failure of the octet and Lewis theory. Okay. Then they are going for the next theory is Sidgwick-Powell or valence bond theory. Valence bond theory means, so you have in detail, but simply whatever the electron available in the valence shell can bond with the other atom. Okay. So you have to see that the valence electron. If you are writing the electronic configuration of hydrogen, it become 1s1. And that hydrogen also having 1s1 electron means, so it will combine, it will form a bond H2. So the criteria is the atom should have unpaired electron. Atom should have unpaired electron. If you take that molecule N2, so 1s2, 2s2, 2p3. So this is completely filled. 2s, 2p electron only we will take. But 2s, 2p's are 1s and 2s are completely filled means you have to take only 2p. You have 3 electron, 1, 2, 3. So one more nitrogen, you have 1, 2, 3. So the 3 electrons combining, it forming N triple bond N as per valence bond theory. So you are taking O2 molecule 1s2, 2s2, 2p4. So when you write 1, 2, 3, 4, you have 2 bond, 2 unpaired electron in each oxygen atom. So it will combine, it will form double bond, right? So by this way, the valence bond theories are explained. But without, so far we are saying, so electrons are surrounded the central atom. This will be how it will become in the 3-dimensional. That gives your shape of the molecules. Okay. When it take along with the geometry, if you are saying geometry, it with the lone pair of electron. If you are saying shape, so without lone pair of electron, you can say the shape. Look. If you are having 2 electron pairs around the central atom means, so you have to consider in the circle. In the circle, you have one vertical circle and then one equatorial circle. As like our Earth, it becomes circle. In the 3-dimension, you have to consider whatever the horizontal circle we are written now, that become equatorial. Okay, whatever vertical circle we have drawn now, that is equatorial, block color. Okay, whatever we drawn in the red color line now, that is equatorial. So this become equatorial and this become axial. அப்படிதான் சொல்லுவோம் அந்த angles axial and equatorial. So you have to consider molecule in this circle. The bond pass will be as apart as possible. If the central atom having 2 electron pairs means the two electron pairs are separated as apart as possible. So when the separation is more, stability will become more. Okay, so total electron pairs, it has to oriented in the 360 degree, it gives the shape of your molecule. When you have only A, means A in the center. If it is AB2, okay, AB2 means, so the two become in the equatorial itself, or it become in the equatorial axial itself, but both will give the linear shape. Am I right? So AB2 means A in the center, B in the, so it gives linear, that bond angle become 90 degree. Correct? Say yes or no? Okay. So when you have same circle, AB3, so how it will become? A in the center, B will be oriented in the 120 degree, either in the axial or in the equatorial. So when the AB3 means A will become in the center, 3B becomes in the, so it becomes triangular and 120 degree. If it is 4, so what will be the shape? 4 means you have two possibility, right? One in the tetrahedral, another one in the square planar. Among the two, which is more stable? This part is very important for the structure. Among the two, which is more stable? So this bond angle is 109 degree, 28 minutes. This bond angle is 90 degree. Among the two, which is more stable? Why the first one is more stable? Bond angle is more. So what I said, when you have the electron pair, how many electron pair will be there? You have to calculate. If it is 4, it will orient into two ways. One is 90 degree, another one is 109 degree, 28 minutes. So when they are as apart as possible, the stability will become more. So that is why you are taken a methane molecule. Methane is tetrahedral, but the bond angle is 109 degree, 28 minutes. How it will become oriented? You have the A like here, and the 2 become in the 109 degree, and 2 become in the equatorial. So that's why we are saying in the tetrahedral, 2's are in the plane, 2's are the whatever I put it in the dotted line, no, that is backside of the TV. Whatever I put it the shaded line, no, that is towards you. That means that solid line represent the two lines are in the TV or board itself. The thick lines are towards you, and the dashed lines are away from you. That means backside. So that's why in the 360 degree you are getting. And then so AB4 means tetrahedral. The bond angle is 109 degree, 28 minutes. And then AB5. So what is the possibility? When the A molecule in the center and the 3 B's are become like this. AB5. So B, 2, 3, 4, 5. So if you are connecting, you will get trigonal. Okay. When you connect upper side, trigonal pyramidal. So up and down you have that. So what is the shape? Trigonal bipyramidal. Okay. Is it clear, ma? Is it clear? And AB6. So A is the center. 1, 2, 3, 4, 5, 6. And B will be in that. So you can say when you are connecting 4 B's, you can get square, right? square bipyramidal, or otherwise it is called octahedral. Why it is octahedral means 4, 1, 2, 3, 4. Okay, the atom one will be the 5, bottom one will be the 6. If you are connecting, the 4 will become in the square, right? You are getting like this. The upper one, bottom one. When you have this, you connect 1, 2, 3, 4. So 1, back side 2, this side 3, this side 4. You have 4. Same way, you have 4 in the bottom. So how many phase you are having? 8 phase you are having. That is why it is called octahedral. Okay, octa means 8. Same way, tetrahedral, if you are seeing, you connect this 1, 2, 3, 4. 4 phases you can get it. 4 triangles, bottom, 3 sides. So that's why you are saying tetrahedral. Is it okay? This is the shape of the symmetrical molecule. That means you have only the bonded atom. So the bonded atom in the central atom, it will be oriented like this. Okay. Now you have to go for the VSEPR theory. So VSEPR theory, valential electron pair repulsion theory. So this theory gives us the simplest idea of the molecules, structure of the molecule. It doesn't involve any mathematical calculation. So if you are going for molecular orbital, you have to calculate what is the energy of the s orbital, what is the energy of the p orbital, how it becomes shaped, like that you have to calculate. For the VSEP theory, it doesn't involve any mathematical calculation. Only you have to identify the central atom and the peripheral atom and what is the valence electron. And around the central atom, what type of electron pair present. So there are 2 types of electron pair present. One is bond pair, another one is lone pair. So now you have to calculate number of electron pairs. In that, how many bond pairs and how many lone pairs. You have to orient in such a way that it gives the shapes. Here they are telling that first 2 electron pairs. That means bond pair and lone pairs. Okay. Then first you have to identify the central atom and peripheral. Central atom and peripheral atom, bond pair, lone pair, and then if you have only the bond pair, it get symmetrical structure. Whatever we are saying in the above, is there no that structure? Suppose if the bond pair, the overall electron pair contain lone pair, it will not have the symmetrical structure. So it will have the distorted structure. So you are expecting tetrahedral means it will not have the tetrahedral. Instead of tetrahedral, it has some other structure. Okay. So we have the 2 electron pairs now. If the molecules having bond pair means you have only symmetrical structure. Lone pair means distorted. So the magnitude of repulsion, how it will become? Lone pair, repulsion is more than the lone pair, bond pair. This you can simply take an example. So all of you are sitting very casual in the seats, right? For the bulky person come and sit means it's possible. So what happened? There will be some interaction. If you are traveling in the MTC bus, 2 bulky person can sit in the 2-member seat. So what happened? There will be some repulsion. So one bulky person and one like you people you can sit 2 members, or like you 2 people can sit simply. So there will not be any interaction. But when the 2 bulky persons are sitting means there will be interaction. The lone pair can be present on the only one atom. If you are taken the molecule எடுத்துக்கிறீங்கன்னா அதை பார்க்குறீங்கன்னா central atomல the lone pair present on the atom, but bond pairs are between the atom. So if you have bonded atom AB, means the bonding electrons are present between the A and B. So 1 electron A, 1 electron B. Whereas lone pair means it present on the atom. Okay, so the lone pair present on the atom, The bond pairs are delocalized between the A and B. So what happened? The lone pair occupy more space. It occupied in the only one ஒரு ஆட்டத்திலே ரெண்டு எலக்ட்ரான் இருக்கு அப்ப it occupy more space. That's why lone pair interactions are more than the lone pair bond pair. Then bond pair. If the molecule having two lone pairs means that interaction will be more, it occupy more space, then the bond angle get reduced. Okay, va? Same way, if the molecule have triple bond, so triple bond cause more repulsion than double bond, which in turn more than the single bond. That's all. Okay. Now, how to find out the total electron? So, total electron pairs is equal to valence electron of central atom plus number of attached atom. You have to consider only the monovalent. Okay, plus number of anions minus number of cation. If the cation present, you have to minus it. How many units? That unit you have to minus it. Anion means how many anions is there, how many units is there, you have to add. That divided by 2. Why you are dividing by 2? You are calculating the pairs. Okay, so you can take the simplest example, BCl3. What is the central atom? What is the central atom of B? So boron means 1s2, 2s2, 2p1. What is this electron, total electron pair? Total electron pair எவ்வளவு இருக்கும்? Valence electron of the central atom, how much? Boron is the central atom. You said 1s2, 2s2, 2p1. What is that valence electron? So 3. So number of attached atom. What is the attached atom? Chlorine. 3 chlorines are attached. 3. Cation is there? No. Anion is there? No. Right? So the whole thing divided by 2. So 6 by 2, 3. So total electron pairs equal to 3. Okay. You have to find out lone pairs. So lone pairs equal to total electron pair minus attached atom. So what is the total electron pairs? 3. What is the attached atom? 3. 0. So it doesn't have the lone pairs. It have only the bond pairs. So if you have the central atom, the 3 atoms are bond pairs. What will be the structure? AB2. So look here. So AB3, what is the structure? It like this molecule, no? What is the structure? Huh? Triangular. So it become A, B, B, B. So we have only 3 bond pairs. The 3 bond pairs in the 360 degree. Okay. 360 by 3, how much? So it become 120. But if it is 4 means, you will not put 90. Remember, no? Because it has more interaction. 2 in the equatorial, 2 in the axial. So the bond angle is 120. The shape is triangular. Is it clear? Is it easy? Can you do for one more molecule? You do for NH3. You tell me what is the valence electron for nitrogen? For nitrogen. 5. So the total electron pairs equal to 5. How many attached atom? How many attached atom? So 5 plus 3, 8. 8 by 2, 4. So total electron pair is 4. Then lone pair become 4 minus how many atom attached? So you have 1 lone pair. Suppose if it is 4 means What is the shape? What is the geometry? If it is 4 electron pair, what is the geometry? AB4. What is the geometry? Tetrahedron. It become like this, right? But due to, so the bond angle become 109 degree 28 minutes. Due to the lone pair of electron present on the nitrogen, it reduced the bond angle of your NS3 molecule. So what happened? It occupy more space. The 2 electron. Then the bond angle become getting reduced to 107 degree. Hydrogen, hydrogen, hydrogen. So shape is pyramidal. So without leaving the lone pair of electron, for the shape you can leave that. So that's why the shape is pyramidal. So you can calculate for CH4 methane. So total electron pairs equal to 4 plus 4 by 2, 8 by 2, that's 4, right? So 4 means what you can get? 4 electron pair, because lone pair is 0. 4 minus 4, 0. So we'll get 109 degree, 28 minutes. Whereas ammonia, though it has 4 electron pair, but the bond angle is 107 degree. Why the bond angle get reduced? You know that the magnitude of repulsion, lone pair is more than lone pair, bond pair, which in turn is more than bond pair, bond pair. So here no repulsion, but here you have lone pair, bond pair. Repulsion will be there. So the lone pair present on the single atom, it occupies more space. Is it clear, ma'am? So you can try for H2O molecule. You are liking molecule, no? H2O. Oxygen is the central atom. So total electron pairs equal to oxygen 1s2, 2s2, 2p4. So 6 is the valence electron plus 2 hydrogen atom, that divided by 2. 8 by 2, 4. So 4 minus 2, 2. So 2 lone pair. So 4 means it becomes tetrahedral. But the 2 lone pairs are present on the oxygen atom. You know that the lone pair repulsion will be more. So still it reduces the bond angle. So the water become HOH become 104 degrees. So simply the VSEPR theory is beautifully explain why the bond angle get reduced. Though nitrogen NH3, CH4 and H2O all are having totally 4 electron pair, but the bond angle get reduced. Why? Because of this reason. Is it clear? Is it clear? So now I will put simply whatever your book is there, no? So AB lone pair, bond pair. So AB2, you have only 2 bond pair. So you have AB2 types. Okay. Here bond pair, lone pair, and then shapes. Okay. AB2, you have only 2 bond pairs. Then shape become linear. And the bond angle is 180 degree. So ABB. Okay. And then AB3. So 3 bond pairs, no lone pairs, triangular. You should not forget this one. 120 degree. So A, B, B, B. And then the bond angle is 2, the lone pair is 1. Then it become bent shape. So the bent shape means less than 120 degree. So what will be the shape? A, B, B. Then AB4, 4 bond pairs, no lone pairs. We have 4 bond pairs, no lone pairs. Then shape is tetrahedron. 109 degree, 28 minutes. So AB4. Then 3, 1, then pyramidal 107 degree, A, B, B, B. Books la nalla irukum shape. And then 2, 2. Then bent or V shape or angular. Anything you can say. How it become A, B, B. This is the conclusion of VACP theory. So you can arrive, okay? And then AB 5, 5, no problem. Then trigonal bipyramidal. So symmetry get distorted. So how? A, B, 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 B. So this will become 120 and this become 90. So the bond angle is 120 and 90. Correct? So 2 bonds are present in the equatorial is 3 bonds present in the equatorial is 120, 2 bonds present in the axial is 90 degree. So then you are reducing 4 by 1. So one of the B get replaced by AB4E. That means E means lone pair. We are saying what will happen? One of the lone pair. Now the excellence of ASP is present here. That E can be in the axial or it can be in the equatorial. Now the question comes in your mind whether the E lone pair present in the axial or equatorial. Logically you say where it becomes. Why? Okay. Now the repulsion irukada. So in case if you have here lone pair means okay 90 degree, 90 degree, 90 degree. You have 390 degree repulsion, no? In case if you have lone pair over here means 190 degree, 290 degree. Here 120 degree. Where the repulsion will become minimum? Where it will become minimum? Huh? So here you have the lone pair. Okay. Here you have the lone pair. 1, 2, 3 atoms are 120 degree level. Appo one is 90 degree, second 90, third 90, 390 degree repulsion will have. In case I am having over here, இங்க வந்து B இருக்கு, கீழ B இருக்கு, இங்க இருக்கு. அப்ப என்ன ஆகும்? This lone pair having repulsion with 90 degree, same in repulsion with 90 degree. And here it become 120 degree. So you have only 290 degree repulsion. So you see where the lone pair become. Here or here? Here, what is that? Equatorial. That's all. Very good. So if the shape you are seeing, it will become like this, no? Where you can see, in the part you can see seesaw. The shape of the molecule becomes seesaw because the lone pair going to occupy in this position. Here A, B, 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 B. So this is seesaw. நான் அப்படியே உள்டாவே எழுதுங்க புரியலையா? A, B, B. இதான் நான் அப்படி உள்டாவே எழுதிருக்கேன். உனக்கு சீசா காமிக்கணும்ன்றதுனால so these two are one and the same because these three are 120, these two are 90 only, no? You have to look at molecule like here also if you are seeing 90. Don't say it, no. இப்படிதான் எழுதிருக்கேன் ஆக்சுவலா இப்படிதானே இருக்கு மாலிகுல் சீசால எப்படி ஷேப்னு புரியணும் இல்லையா அதுக்கு திஸ் இஸ் நாட் ஈக்குவல் ஆக்சைல் ஆக்சைல்னா இது ரெண்டு தான் பர்பெண்டிகுலரா இருக்குன்னா ஆக்சைல் மூணு வந்து ஈக்குவல்ல ஷேர் ஆயிடுச்சு அதுக்கப்புறம் தான் ஆக்சைலுக்கே போகுது ஃபர்ஸ்ட் இப்ப ஷேர் இட் தி ஈக்குவல் then we will go to the axial அப்பதான் வந்து சேமா இருக்கும் அப்ப என்ன பண்ணுதுன்னா 5 electron 3 are separated to 120 2 are separated to 90 clear got it no அவ்வளவுதான் டைம் முடிஞ்சுச்சா அடுத்த கிளாஸ் இது என்ன டே the Saturday will continue and then we'll complete this portion okay are you happy with this class are able to understand is it clear no whatever you are having doubts you can clear so next class means we will go little faster okay இங்கிட்ட இருக்குமா You guys can also actually so because of the fans, it is important to why you get that. Okay, so every time you slide the complex number assignments and 23 problems. We discuss all of the problems. Only use to address it. Discuss all the problems, but still some of only these two were. So we have chemistry, chemistry. How is chemistry? Which chapter? Is the next lesson? See,